Good morning, everyone. Today I'm going to present our final project report presentation. I will talk about the first 2 points, which are the summary of the system and code description. And then Solita is going to take over to talk about the result and conclusions. I would start with the summary of the system. As you can see, this is the facility of the FedEx business. I think by now you can dream in it, not even think about working on it that long. So this facility receives about 10,000 two trucks, one at 5, the other at 6 p.m. We considered 10,000 packages and 5,000 packages for each truck. On the right side, you will find the schedule that's given in the project. The facility has a total number of 10 workers. We assigned, as for station 2 and 5, they have 4 workers. So we assigned 2 for each of them. For station 3 and 4, they have only 3 workers. So we assigned 2 for station 3 and 1 for station 4, and then the rest 3 workers for station 1. On the very right is, as given here, the mean handling rate packages per person. For example, for station 2, a worker can handle 4,800 packages per hour. We took the inverse of that, as you can see, in order to get the processing time, how long for a worker to process 1 package. And in the bottom here, we listed our 2 study questions for project 1 and 2. For project 1, as you can see here, does changing the conveyor belt speed help to achieve the business goal of delivering 95% of the small packages? And then for the second study question for project 2, we focus more a little bit about the work efficiency, whether it helps the business achieve its goal or not. Code description. This is how we coded the facility on the Simio. As you can see here, we created 2 entities, small and large packages, and also we created 2 sources and 1 sink that are represented by the FedEx, 3 FedEx trucks over here. For the sources, it has the capacity of 5,000 each truck, as I said, mixed with small and large packages. And this is how we told Simu while generating the entity into the conveyor belt to mix those up. This is the table for that. And then, as you can see, we created the 5 stations here, represented by the airport bag scanners. And for each station, we have the given data over here, which are the processing time for each station, as we calculated in the first slide, and then the initial capacity of each station, and of course for the initial desired speed that's given 25 feet per minute. So here, as the packages comes in the conveyor belt, when they get to station 2, they split it between large and small. Small packages goes back to station 3, and this is the combiner node that we created. What it does basically, it combines the small packages or holds small packages until it gets to a size of 25. When it gets to the size of 25, it turned to a large green package, as you can see here, pushed back to the conveyor belt by station 4. And then to be ready to ship for the outgoing truck. For add-on processes, we created 2 add-on processes. The first one is for the combiner node. As you can see, this is the screenshot, how it looks. What it does, as I said earlier, hold the small packages as it gets to 25 and then send them. For the second add-on process, we created the add-on process that computes the total number of small packages. How we created that, as you can see here, the large green packet, which contains 25 small packages. When it gets there, it's considered as a 1. And then the second green package that's on its way, it's going to be added to that. So it gives us the total number of the large green packages. And we trigger it under the add-on processor for the sync. For the experiment, the last thing I want to talk about in my part for this presentation, we run the presentation for 5 hours, as you can see here. We added response. This is very important because it's going to tell us whether the goal was achieved or not. So how we added that, how we code it in the simu, we give it a name as small package percentage, and then under the expression we come up with this formula over here to count the percentage. Count small packages. This is the total number of large green packages, as I said earlier, the total of that, multiplied by 25, because each large green package contains 25 small packages, give us the total number that were shipped by the end of the simulation, then divided by 5,000, which is the total number of small packages in the whole system from the tow truck. We have a bunch of scenarios over here. The first two scenarios related to the changing the conveyor belt speed for project 1. And then the second box, the blue box over here, it's our first relaxation. We relaxed the arrival time for the two trucks. And instead of having them fixed, so add 5 and add 6, the second one, they arrive, we relax it using the distribution here. Green box over here is our second relaxation. Now we relax the processing time beside the inter-arrival time as well. And for the last box here, it's our two scenarios for project 2, which were focusing on the improving the efficiency for station 2. As you can see here, this is the processing time for station 2 and 3 and 4 and on. But I'm going to focus on the station 2. We changed the mean handling rate, as you remember in the first slide,